Okay, so let's take it away, shall we? Once again, please let me extend a warmest welcome to all of you joining. I hope we're not going to have any technical difficulties today, and you can hear me well and see the screen well. Topic for today is prototyping data science use cases, and especially with KNIME. We're going to talk more about what's KNIME and why do we think it's particularly relevant for data science use cases. Let's set the stage quickly. When we dreamt up this webinar series, what we imagined is to take very practical examples, right? I would rather say that let's take the big picture, let's understand what's our best practice approach, what's our methodology on prototyping data science use cases, and let's take particular examples and walk through them to see, how this plays out in real life in action. We would like to actually address all stakeholders in this story, right? Both to give them an overview in terms of process and how this can work out for the organization, but also for the enthusiast, the citizen data scientist, and the expert data scientist between us who would like to learn something and take away this as a blueprint, what we showcase here. So that's already highlights kind of the duality of this agenda. First, we're just going to take a couple of minutes to do a quick introduction of EPAM. I hope most of you have heard about it already, but if not, we're going to briefly introduce the company and its history. And we're going to talk about KNIME, what are the strengths of KNIME, and maybe a couple of words about our partnership. The next two blocks are about methodology, basically. But again, we'll be sharing lots of practical advice, and then roughly the second part of this webinar will be a deep dive. So we're going to look at specific algorithms, logic, implementation details, visualizations, and all the nitty-gritty details that actually make these use cases work in real life. Okay, so let's introduce EPAM. EPAM is, I would say, if you look at the DNA, it's an engineering company that's diversifying it nowadays to be able to become and actually already is recognized as a premier partner in digital transformation and data-driven transformation. I mean, these are somewhat overused terms, right? So, but we're gonna, for example, and what I can help you in particular is data-driven transformation. We're gonna show you, give you a glimpse of basically how we imagine such a program. How we see this play out at the largest global players. Fast facts. Yeah, there is plenty of history and the history of growth and success of EPAM. It's a truly global company now of more than 20,000 colleagues and global presence. Quite a diversified portfolio. Within that, I'm part of the enterprise analytics solution practice, where, as I said, we deal with we help companies travel this analytics journey and help them mature along this path. So if I would need to classify, for example, ourselves, I would say we're consultants and engineers, mostly. I would say, I should say, we'll talk about where data science falls in and how it compares to, for example, traditional software engineering. There's a separate block. We'll cover that. And we have an end-to-end portfolio, basically, of how we guide companies through this, how we help organizations through this process, from consulting, design, construction or engineering to operation and scaling, optimization. Let's, I really hope that I don't need to introduce KNIME. This is not meant to be kind of a first course on KNIME, so I won't do a detailed platform introduction. I think there's very good resources done on KNIME's website, so I just would like to give a high-level overview here, and we'll talk about some particular capabilities of the KNIME as a data science platform later. So I think what's apparent is immediately when you look at it that KNIME is a visual platform. It's a visual workbench, right? Basically, you can implement your logic, you can implement an analytics solution visually by using nodes, which is the, so to say, atomic unit here, and combine them into workflows. What's actually still puzzling to me is that how let's say, why this ecosystem already grew. KNIME has been around for quite some years, more than a decade now. There's more than 2,000 modules or nodes you can use to build your pipeline. And what KNIME is primarily is a data science platform. It's a quite typical use cases also include self-service analytics and also data wrangling. And it has really kind of anything and everything for that. And what sets, I would say, KNIME truly apart from its competition is that it's open nature. That first of all, it's very inclusive. So it gives you tools to use latest, for example, machine learning platforms, just like H2 Emerged. It already has nodes to run machine learning with H2O. It has big data connectors. You can connect your ERP systems from it. And also EPAM is a partner of KNIME here in terms of development as well. We create connectors, for example, to SAP HANA or SAP BW, Spotfire, and myriad other nodes we have also in development currently. This is an interesting chart, and I would say for those of you who are coming from an R or Python world or coding world, there might be a let's say time to embrace this. But KNIME really, I think for business users or users coming from the business domain, this will be pretty apparent. It's a very handy tool that really helps you along your self-service analytics or along your prototyping. But those coming from hardcore data science, I think they'll need to see really this kind of diversity and possibility to embrace Python, R, Java, big data platforms, executional Spark, and all these capabilities what KNIME has to offer for you to really realize how much it really tries to help you to get along. And why do data scientists say this is Rexer analytics survey actually, that it's a platform that drives very high user satisfaction. But it's not just these software specs. Actually, it's very worth to mention that KNIME is very well recognized by Gartner as a leading analyst. They're being in the leading, as classified as leader in the Magic Quadrant for data science platforms for the 4th consecutive year. So I would say there is definitely plenty of industry recognition behind KNIME. Okay, so our next chapter will deal with our methodology. And first of all, we'll look at, as I said, we take a big picture approach, and for me, I think this is really one of the most important things. We'll start with identification assessment, right? There's lots of hype nowadays in AI and ML. I think we can say that it's probably at the peak of the hype curve, maybe we're slightly already past that, but somewhere there, right? So we see lots of executives, not just executives actually, on every level of the organization. Everybody realized that analytics and predictive analytics for data science or advanced analytics, lots of name for it, is definitely a key driver of innovation and a key driver for companies and organizations to leap ahead and differentiate themselves. So lots of organizations are at this very stage right now to see and identify what would make sense, in their circumstances, what would make sense in their context. So what we have came up with here is a structured methodology, actually, right, which guides you through this process, helps you identify and assess use cases, gives you some guidelines of how you can prioritize them. And again, what we'll focus on today is how you can actually prove the value of these ideas, how you can test them before committing to let's say, large implementation. So what are the cornerstones? Well, technically, we do usually this as interviews, right? And we collect information, and I already would like to highlight here two things, right? First of all, you need to talk to the right people in terms of there's lots of gains, what you can gain using data science in automation. So that's saving time, right? It's kind of bottom line cost savings. There's lots of savings you can also have on the top line, revenue. And actually, the third kind of impact data science can have is managing risk. Actually, we like this kind of three kind of impact classifications were coined by Ben Lorica, or Riley's chief data scientist. Coming back to the previous point, it's worth to highlight that you're not alone. So you're not the only organization in this assessment, and there are already libraries actually of kind of analytics use cases and advanced analytics use cases out there. We can help you, or you can actually reach out by yourself, right? So there's already publications on this, research on this, and this can be very useful to actually identify what's relevant for you. And let me come back to why inventory optimizations. I'm actually very delighted to see that so many of you are interested. If you look at McKinsey Global Institute's recent research, where they did actually a collection of AI, what they call AI or ML machine learning use cases, they identified supply chain management and manufacturing to be the second largest or second most impacted business function in the organization, right after marketing and sales. Right, so that would be a very, very valuable feedback also in your identifications and where you should focus on. The other thing I would like to highlight here, and that's extremely important, is data. The reality is that, and if you look at, I think it's Crowdflower who did this data science report, and they asked data scientists, what is your number one challenge? And they said it's quality data. So basically, this already gives the kind of two approaches you can shoot for. One is to aim for the highest business impact, which obviously you should always do, but at the same time, understand your starting point. And as I said, you have to be clear what is the data that's really good enough to gain insights out of. And most often, this is going to be basically data recording your core systems, your core, for example, ERP systems, because that's curated, that's cleaned, so to say, battle tested in day-to-day business, right? And you can always, of course, always augment this data from data marketplaces or even public data, but that's going to be your cornerstone, right? So it's I would say you can get faster to your time to value is going to be higher, so it's lower. So you're going to get faster an impact or ROI if you take into account what kind of data you can really build on. Otherwise, and this is again well documented, your data science team will most likely spend a significant amount of time just collecting data and then cleaning that. Okay. So prioritization, that's also key. Here again, I think what's maybe worth to come back to identifying use cases. Have a cross-functional team do this, right? Have a kind of product committee who understand both data, the very important, we'll talk about this, the domain, the business domain you're seeking to transform, and have them shuffle and prioritize these use cases. Here we built actually an actual solution. There's also an executive dashboard coming to this, where we help and facilitate this process. Actually, EPAM has, or EnterpriseAnalytics provides this business case collection and prioritization service and platform for that. Assess, I would say, already in this prioritization, again, assess your data quality. And it also assess one more thing when you prioritize data infrastructure, right? So let's say if you have terabytes of data you would like to go through and not the proper infrastructure for that, that's going to be a challenge, right? Then maybe rapid prototyping is not the best approach there. And then first you need some groundwork to do, right? Some lay up the foundations for your data infrastructure. And again, that's why again a cross-functional team, including can shine here and guide you through this process. Okay, so let's see how we do this, how we envision the actual process of proving the value. I think there I said it. So the value proposition of rapid prototyping is exactly here. This is a tool, or we envision it as an internal service that can help prove all these ideas and drive basically innovation and help innovation really take place inside the organization. So how we envision this to work? We envision this as an agile process. Again, cross-functional teams, and we imagine this to be. I think I just was listening to a podcast today where they said that you shouldn't say fast fail, but fast learn. I would rather still like to quote the word fast fail. This is your way to have a kind of cost-efficient testing of an idea. And actually, maybe I can already jump ahead a little bit. There's various things you can prove while prototyping. Value, or let's say, of an idea, of a business idea, of a concept is one thing, right? You can again prove your data, you have the right data. You can prove, and that's actually surprising. It often comes often if the requirement and need of the organization is really real. Again, that's if you that comes through having a hybrid team do this, and having the people who need to who have a need, who have an organization and need to improve let's say process, who would like to have some innovation in their field. Have used this rapid prototyping, for example, to validate this organizational need if it's really there, and if the impact, I would say, is really there, provided it's got second production. Prototyping helps validate feasibility, or at least get an idea of. We're going to talk about this. That the reality is that the prototype is a prototype, and you're only going to get real value out of it as an organization if you put this to production. And let's go back to that data science report of Klaus Parda was quoting. The number 2 challenge they were highlighting, and I think this is not just for data scientists, but stands for organizations as well, is how to put data science solutions, prototypes into production, or models into production. That's a very significant challenge, and we see lots of organizations and customers of ours asking us about this. Team, rapid prototyping can also validate team. Data science platform, it's something very interesting and relevant, and I think lots of you were probably in the middle of a data science platform selection and evaluation. And rapid prototyping can already give a glimpse, as I said, of what it takes to go to production, but we're going to talk about that later. How should you approach data prototyping? And then I would rather dive a little bit into the data science specific aspects here, because rapid prototyping is actually a generic service. we provide it to create analytical dashboards, analytical solutions. But what's specific about data science? Prototyping implies a feedback loop, right? So the idea is that you have to be able to iterate very quickly. And there is some technical implications here, right? You have to have the right platform, or right tool set. And what I mean by it, and let me reach out to this whole topic, a notion of big data, right? Big data versus small data. When I was preparing for this webinar today, I was looking for a good definition, because big data is such an overhyped term nowadays, right? I think we're definitely past the hype curve there. But it still can be kind of anything and everything. So how do you distinguish between big data and small data, right? And the best definition I found is that if you can fit all your tools and memory, all your tools and data into memory, whatever your kind of infrastructure you're working with, then that's like not big data for you, right? But it also means that you'll be able to handle that, right? And that's limit, right, where you can see that you need a big data environment. This particle will be for data science will be not just a Hadoop like a storage environment, but actually an execution environment more like Spark, where you'll need to distribute all your data going in a cluster to be able to process it, right? So the practical implication is here that there is a lot you can do in like in a simple notebook with some consultant data scientists. If you have the possibility, you can just go and rent a large server in the cloud. That's already like half a terabyte. You can buy, I just checked, almost half a terabyte machines for a couple of dollars an hour, right? So there's already actually a lot more than let's say what you would think out straight away. Why is this relevant? Because as I said, it's a feedback loop, and you have to be able to iterate. So that means you have to have the capability to change and rapidly alter your model multiple times a day, right? And that's why I say it's really important that you have your good starting point, because if you try to process more data, if you haven't sampled down your data, or you haven't sliced and diced and identified a usable and good enough starting point where you can do this rapid iteration, it's going to fall apart. And we've seen this happen, right, quite often. So it's really important that you have to. Rapid prototyping is not the scale solution phase, right? It's not that you build it. You have to be able to prove the value what you're sending out, but it's just to get there you have to be able to iterate very quickly. For that, as I said, you can just use your notebook, or you can get a large server like KNIME has, for example, cloud servers you can rent out on the hour, and you can just deploy your workflow. You can deploy your model there and then have it trained there, right? Just another related piece of advice: use in-memory tools, right? It's not just the largest ERP providers who have in-memory tools nowadays. There's lots of tools for that. KNIME can do in-memory. You can get SQL and a SQL-based embedded database, even open source database like SQLite, using memory tools. These are really important practical implications here. One more thing as kind of key enabler for your prototyping, your analytics maturity, right? Where you start from. For example, do you have data dictionaries? Do you have good business definitions of your KPIs? Right? Is this knowledge ready available? Is the knowledge of your data, your business domain, and how they come together ready available? Can your colleagues easily share it with the team doing this discovery and doing this prototyping? These will be absolutely key drivers in the I'd say value generated in such a short time frame. Okay, Agile. It's a question often comes up, and we'll actually. On the next slide, you see already sprints here, right? So Agile is certainly all around us nowadays, right? And this comes actually for software development from the Agile manifesto, but it's a phenomenon that's really pervasive right nowadays, right? So it's transformed, I think, also how we think about running business and reacting actually the rapid changes around us. It's really important to know that data science is not software development. There are some things you can take and put into kind of an agile, like a Scrum framework, that can be well planned, reasonably well planned. Let's say some of the data wrangling tasks, right? But lots of the tasks, when data scientists iterate and try different algorithms, or try to find what they call features, let's say key drivers of let's say attributes of the data, attributes of the business, you can build a model in to do predictions. As I said, this is iterative in itself, and lots of it cannot be planned, right? And also because the field is relatively new, sometimes you might just need to do and reach out and do research, like read even university papers, right, to get to the cutting edge algorithm. And what I mean by that is that you should divide tasks, or let's say structure your project in a way that certain tasks will lend themselves well to Scrum or an Agile methodology, but certain tasks regarding data science, model building, and experimentation, right? Data science is about the scientific method, right? It's about having a hypothesis and testing and that hypothesis and experimenting around this, right? This is something which will not perfectly fit. What you can do there, though, is to time box them, right? To set a limit to make sure this is kind of on topic. It doesn't become like an encyclopedic research. Why is that also relevant? Because in rapid prototyping, you also want to identify what you can quickly deliver, right? It's all about time to value, actually. Team composition, hybrid teams, we already discussed that. Gartner has a nice write-up on personas. They already include machine learning engineer, which I would say can be an added value, can have some added value if you already look for a quick implementation cycle and you would like to see it go to production quickly. So at least identify and verify if it can and how it can go to production. I think it's not essential. Our usual team composition is more like data scientist as a cornerstone and business analyst and maybe data analyst as a good triangle. What's essential here is the domain expertise, right? There is absolutely no substitute for that, right? And we're going to talk about that in what we call guided analytics, how we think how data science and domain expertise or business expertise can complement each other perfectly, and what's a good way to do that, right? Because data science is, I would say that the best value will mostly likely not come just by automating out, chores inside organizations, but actually augmenting human knowledge and human creativity. Well, we'll talk about that. We'll show you some very practical example in the second part. Okay, so time is, we'll soon need to move up. So there's one last thing I would want to cover here, and that's choosing a platform for data science, right? This comes back to that third point in the data science report, that moving to production is the hardest part. But at the end of the day, for an organization, the most important part, right? If you can't put something into production, then it was at best a thought experiment, right? Could be worthwhile itself. And by the way, prototyping is not always about having a working prototype. Sometimes you actually deliberately can set out to build a throwaway prototype and still gain value out of it. But by and large, we're largely looking for putting machine learning into production. Due to limitation of time, I just would like to highlight this, that do recommendation that it's worthwhile to invest in research. It's worthwhile to already have a platform. There's lots of great, fantastic open source tools otherwise, and you can see that this market is really moving and embracing and kind of living and breathing open source, right? But there's already different platforms supporting this ecosystem, and if you choose already a platform that can take you to production, that's a huge gain, right? That's one less hurdle to jump over again when you want to go to production. Here, I would like to just cite one study again of Gartner, is called "Critical Capabilities for Data Science and Machine Learning." And here, I think I don't want to quote the exact scores and numbers, because I think I'm not sure that's will be embraced by Gartner. So I just would like to say that KNIME received basically top scores in both advanced prototyping, being their probably their strongest points, but also in production refinement, right, which is basically the Gartner term of taking the solution to production. One more thing why it's worthwhile to invest in data science platform, and again, that can be goal for Loving as well, is to make sure you choose a platform that's open and inclusive enough. Because there is lots of innovation in this space, and you want to make sure, and that's something, by the way, what KNIME is, in my opinion, doing really probably the best, or the best I'm aware of, is that you can pull in the latest that's the open source libraries, the latest innovation, the latest TensorFlow version, and use that for your mission and use that for your project. This is really all very important because again, we see even groundbreaking innovation coming up every day, and this whole field is just moving so fast that you have to stay open for innovation if you want to be at the really very edge. Okay. Last but not least, as I said, rapid prototype is a service of ours, right? And we want to make this a repeatable exercise. We distill down basically our experience in providing this service for many organizations. We had lots of iterations around prototyping, and that's how we distill this down to a productized service, where we have well-defined deliverables, well-defined process, team composition, and this is the blueprint is what you see here. You might ask actually why is there mock-up there actually, right? And I think this is probably the best way for me to take you to the next chapter in this webinar. We really do believe, and I think this is perfectly shared with KNIME, and we're prefixing there, that you have to be able to tell your story. And when I said cross-functional teams, I also meant that you have to be able to collaborate with your domain experts, and you have to give them the possibility to enhance your models, to incorporate their knowledge into your solution, right? We even saw this in our prototyping activities, that it just made a huge difference. It's just night and day, right? And that's why we always recommend to have someone from the domain, from the organization join and be present and be an active member of these prototyping exercises. Okay, so let's look at, let's dive in. Let's take a deep dive. Before we open the KNIME solution, and trust me, it's already open here. Right. Let me quickly showcase what's the problem domain we'd like to address in this use case, which, by the way, you can download from KNIME's website. If you just Google KNIME Innovation Notes or just log into their example server, you'll be able to download the full workflow, the full solution. And we'll also follow up with you with some material after the webinar to help you come back and to any of the points we cover here. So imagine you're in a warehouse, right? Let's say your organization, your company is building cars. Right? So what you see in the simple chart on the vertical is your inventory, which is quantity or cost, right? Depends on where you look at it. And your horizon is time, right? So you have, let's say, a certain number of engines or screws or airbags on the shelves in your warehouse, right? Let's say you want to build a new car, so you buy a new engine for that. It's lead time, which is showing you how long it takes for your supplier to deliver that engine to your warehouse. The point of replenishment is when basically a truck arrives and offloads an engine to your warehouse. Inventory time is how long it sits on the shelf till you utilize it, and consumption is where you actually, let's say, if you're a manufacturing company, build your piece of engine into the car, or if you're like a retail company, you might sell, for example, the merchandise. And There is an industry standard methodology we took here, which is called safety stock. I'll very briefly show that because there's a complicated mathematical formula. If you're going to explore our solution, we'll be able to see it in action. But for now, I just would like to come back and look at the conceptual level. Safety stock is meant to make sure that given a certain preference of service level, you can satisfy all your needs. So what service level? Let's say you want to build a car, then service level tells you how it's a business decision, right? How sure you want to be that you're always going to have an engine on the shelf where you're going to build a car. And given basically your behavior, or let's say the trustworthiness, or your lead time of your suppliers for the particular SKU product, and your uncertainty in consumption, right? And then taking this industry formula, you can come up with a safety stock, right? Which is this inventory level, which enables you to deliver that car or satisfy that need you're going to have. If you have both inventory above it, then you have excess stock, which costs you lots of money. It costs you capital. If you have understock, then you won't be able to deliver, meet your customers' needs. Okay, so this is safety stock explained. I think I hope you get the gist of it now. And let's drive to the particular solution here. High-level flow. We got a good best practice collection now around KNIME, right? KNIME is a free-form tool. What it means, it's extremely versatile, extremely powerful, but I think it's worth to adhere to certain best practice and disciplines to stay structured. And one of the things we did is we built a modular kind of architecture here. We split basically the flow, which is to guiding analytics, to a web portal solution, which is an interactive application, and data preparation modeling. Quite often, actually, we separate modeling out. Especially, like, let's go back to the previous example. You might run your modeling on even let's a Spark cluster, but for example, to consume that model, you usually don't need large amount of computational power, right? Computational power is really needed for modeling, and sometimes data preparation. Okay, so let me quickly switch to KNIME here. So this is their mockup workflow you can also download. This is our data preparation, where again we so not only took and split this workflow into two, but each distinct step, for example, the forecasting we're going to look at, or let's say KPI calculations, is split into its separate submodule using meta nodes, which is a very nice way to structure KNIME workflows. And then we have the guide analytics. So what's this actually? This is a web portal application. Let me quickly walk you through that. So our starting point here was, so this is manufacturing, so we have inventory data, actually, right? Inventory replenishment, inventory consumption. This is the kind of starting data set you'll see if you explore this solution on your own. And what we built here is an interactive application, as I said, which guides you through the flow process, and also helps you to make the focus actually on this key decision. Right? So it's an interactive application. This is not just a dashboard, but let's go there practical. The first thing we did is, or we tried to actually, there's obviously decades, or actually you could probably say centuries of experience in supply chain management. So we didn't want to reinvent the wheel, but we wanted to benefit from our data science, our machine learning expertise. By the way, I think I'll focus now on, as this is the second part, on the technicalities, but as I said, this is a very well documented solution. So take your time, and you can also look at this portal solution. It also runs on desktop, by the way. So if you, let me quickly show you that how you do that. So for example, if you'd like to see this ABC page analysis, you can just open the workflow and look at this interactive view. It also means that you actually can deploy these solutions also in a way on a desktop, like using the standard KNIME Analytics platform. You don't necessarily need the web portal, but the web portal is very fine, and you can distribute it as application. So let's look at it. So ABC analysis is a very classical tool, so to say, right, to identify or structure your how you look at your inventory, right? And the two axes that most commonly taken is inventories in terms of quantity and value, right? So here we got high value but medium quantity items. Let's say it could be in airbags. Here we got large. This is actually SKU, right? The product, a part ID, right? That's a part, a component of a product. Right? So this could be, let's say, screws, quite numerous, but low value. And we got here some, I don't know what could be this, like an airbag or something like that. So what we did here is we actually used K-means clustering. So we clustered this automatically, and what's very nice that it already by default, right, identified 3 typical groups in terms of value, inventory value. Normally, if you look at the industry literature, just Wikipedia, you'll see that there's a rules of thumb recommendation for ABS analysis, and this is already a place where kind of we see that rules of thumb can be a good starting point, but just applying and replacing those rules of thumb actually with machine learning is already where you can immediately recognize value actually. One very important aspect we always focus on, and also rapid prototyping, is that we want to use white box algorithms, not just sort of actually. We always use at least one white box algorithm. What does it mean, white box? If you open up, I think, any article nowadays on AI, the word neural network will come up, right? Let's say you can talk about image recognition, self-driving cars, and all the like. The issue with lots of the approach, which is usually neural networks behind those cases, is that those cannot be explained, right? And there are certainly industries like if you do a mortgage loan application review, you have to be explainable, right? But also, especially early on in this whole journey and in machine learning and data science, you want to build trust in this solution, and there's just no better way to make the algorithms with embedding explainable and explain them actually. And that's why, again, we always build an interface for these machine learning algorithms as well, and ideally an interactive one, like an M9 web portal. So all the users or future users can really explore and interact with them, and not just see them as, let's say, a flat table from a database, or like even if that's going to be the end result, right? You could just say churn likeliness could be just a database column for customer, that's in a CRM system. But when we build this prototype, we want to make sure that our counterparts, our team, can explore and collaborate with the solutions. So let's go back to ABC analysis in particular. So this is actually K-means clustering, which is a so-called black box approach. It's unsupervised learning. What it means that you can run this clustering algorithm on any kind of data, that will actually try to find the centers or groups here. We took these 3 groups because that's the number 3 is what came up in the industry literature, but maybe there's something we could also further explore. And because this is an unsupervised learning, this is a black box algorithm, what we used is to add a decision tree, which is another machine learning algorithm, to actually explain this, right? And what we found, this was actually built a very nice explanation for the classification here, what we did of the SKUs of the components, right? You can see and explore that it actually gives the thresholds of inventory value, where that's kind of helps classify or cluster these products we're reviewing. Okay, so we did a selection. Actually, we can. And now we'll get to the really interesting part. You see, this what we're going to do here. Actually, it's going to be about safety stock. Let me tell you that we actually can do this interaction on a single component, product, or multiple. I selected now basically 2 clusters, middle and high value. And right, and let me just maybe once more highlight that all you see here is actually real. There's no coding right in this web application. That's also the beauty of it, and that's why, as I said, it's a usable tool for prototyping, because in prototyping you have to be able to iterate fast. That means even when you build the interface, which will be actually it will consume significant time, right? So in our experience, building an interface for a machine learning prototype will take easily somewhere, let's say, 1/3 or 40% of the time, of the team's time, right? Well, it's a good investment, right? To help the business users or the fund using tracking the model. But basically, yeah, and even those business users, and this is also something we try to embrace, and we definitely recommend it, but get a simple training, and because KNIME is the kind of tool you as a citizen data scientist can actually use, and even if you're the kind of person who gets excited about such a tool and the possibilities it opens, is where you can interact and actually even build your model or add your own calculation or even change your industry formula. This is a huge value. That is really not a black box. You can go there and see how that whole analysis is built. So this is actually our clustering algorithm, and this is our decision tree, right? You can anytime come here and look at these components individually as well. Solution. Inventory review. So here, these are some custom charts we built. The extent, as I said, EPAM is also. This is actually wasn't coding, just some JavaScript and HTML components. But we also create custom nodes, and we also extend the user interface here. So what we did here, and again, this is kind of public domain, so to say now, and you feel free. You should. Feel free to reuse them in your projects, some KPI components, and this composition chart, which shows you very nicely that past the, I'd say, the ground zero point or the initial point when the forecasting of consumption kicks in, and actually the KNIME is driving the inventory. It's actually driving down the inventory, right? Because this is your supply. You can see that immediately, and these are KPIs we calculate within KNIME. So again, you can trace back and understand how that's done. There's an excess stock. That means we got money sitting on the shelf that we don't need, right? We're not using, right? So this is a kind of the immediate gain here that you can actually free up that capital and take it down. So you see here, we got this this chart dying down, and let me quickly show you actually some of the components we're hearing here. So if you look at guide analytics and inventory view, for example, this is the plotted chart, right? So we give you an example here, and also the comment, we provide comments, and this is a very well documented workflow. So if you want to plot and highlight something like that, and you're the kind of citizen data scientist who's been looking for such a visualization, how to integrate Plotly, which is a very popular library, this is your opportunity to learn from this workflow, right? And so this is where we see the consumption, which is, by the way, what we forecast here. The supply is what we drive or calculate here through safety stock, and inventory is what the end result, right? We got here two, and let's talk about maybe ARIMA to show you the heart of our consumption, right? This is actually the core machine learning, or the core prediction, I would say, what we do here. ARIMA is, and then time series actually is a separate field in itself, also within data science, right? And it's a very versatile approach for time series prediction. Yeah, in a nutshell, AR stands for autoregressive. I think AI for integration, M for MA for moving average. What's really the beauty of ARIMA is that it's a parametric approach, right? So you can fine tune ARIMA, all these three components, and by that you can actually find the perfect fit. You see, I think we were reasonably happy with the light grays here, the ARIMA fit, and the original is the dark one is the original data. or vice versa. Yeah. And you see, we arrived at a reasonable good fit, right? And ARIMA is now, I think, part of the, not just labs, but part of the core, or soon will be part of the core KNIME distribution. And it's a very good approach. Is it the only approach? No. Could you use neural networks for prediction? Yes, you could. But, for example, neural networks, again, is not the kind of holy grail, right? We actually tried, by the way. Right? We knew it probably wouldn't work because we don't have enough data here. You know, you need really large quantities of data. The advantage of that is that it can learn all your features, and we can arrive very good at very good results if you have the good quality and high amount of data. But here we actually had to make do with what we have, and we found ARIMA to be the best solution. For the parameters, we did some manual exploration, but what you could also do and how you can improve it is, for example, it's possible to optimize this, right? That's when I said, for example, in a scenario where we are running in production, because of course the behavior of your industry, of your business might change. I mean, also your suppliers, you might want to, let's say, once in a while retrain or refit. Is maybe the better word for this. So you could physically, for example, run ARIMA on a separate machine or separate cluster overnight. Take those learnings, save it in the model, and actually in that case you would use the model you trained as input to the predictor, right? You would not learn inside the model. And by the way, we train here one ARIMA model where we fit ARIMA for each product separately, right? To arrive really at the best accuracy. So you could do this retraining for every product, let's say overnight from a separate infrastructure, save that model and apply that in your prediction. Okay, balanced error. So basically this is, so you could say this is 28%. So what it means that our overall accuracy is around 72, right? Which is, I think, something we were fairly happy with. Took a while to get there, but we were fairly happy with this accuracy. And let's look at how all these calculations and how let's say this solution comes together and becomes let's say this kind of poster child for guided analytics. This is interactive application, right? So you can actually, as I said, set the service level, which means the optimal choice between customer satisfaction and, let's say, cost, basically cost of inventory, right? So it's an inverse proportional relationship. The higher customer satisfaction you want to have, of course, is the more value you need to put into your inventory. We haven't linked this to a model, for example, that could be a churn model, for example, to assess impact, right? That could be, again, a next level, like a production readiness, right? To really assess what's the impact if you have a certain service level setting. But what's happening here is that based on your service level setting, based on the inventory you have, based on the behavior of your suppliers, again, from the service level, we deduct and this behavior of suppliers from the consumption we forecasted. We calculate the safety stock, what you need, right? And based on that, we calculate your supplier, your order plan, right? So basically, we can drive the orders in this case. And what we can also do, and that's again part 9, is that, for example, this is an interactive application, but the result of this order plan, you could actually go and take it and write back, let's say, a supply chain management system to DBMS, and by that complete the full circle. Right? And also, as I meant, you could actually take this as such then and deploy it as a end-to-end predictive application and interactive application. Okay. Good. I hope you found this an interesting case, right? I hope you also some of the particular, let's say, implementation details were also interesting, at least for some of you or many of you. As I said, I would kind of recommend if you're so inclined to dive and then invite you to also explore this this use case. You can find it on KNIME's webpage. If you Google for innovation notes, you can download it and, for example, check any of your formulas. You can use it as a blueprint even, right? Here, for example, we see excess stock value, so let's say the financial value, which is like one example here, one KPI we calculate on the menu where we calculate unit cost of products multiplied with the number of products we have. And you can actually go and verify and look at any of all of these KPIs and calculations. And I really hope that this will ignite your imagination as well in terms of what data science can do for you, how you could approach it, how you could embed it, and why guided analytics is a very, very powerful impact to really get the best, identify the best value, right, and really rely on the knowledge in your organization and your domain experts. And why do we, and hopefully when you're reviewing this, you'll see why we also so excited about this. I would like to thank you very much again. We'll be coming back to all of you in this in a follow-up. Thank you. Hopefully, we'll be able to provide all these materials and some links to this solution. And last but not least, this data science prototyping we also provide, EPAM provides as a service, right? So this is again the rapid way to prove value, to prove an idea you have where you think data science could be helpful. Okay. Thank you very much for your time. If you have any questions, I think I'll give a chance for you to probably get back to my email. You can reach me anytime, so feel free to shoot an email if you have any questions after this session, and or you can also contact us at EnterpriseAnalytics@epam.com. Thank you very much for your time. Have a fantastic day.